This is exam 3 for Physics 102, spring 2013. A ray of light strikes a thick sheet of glass. So here's the glass. Ray of light comes in at an angle of 25 degrees. With the normal, find the angle of the ray reflected off the glass surface. So this is reflected off, it says, and so that angle, just by the law of reflection, is 25 degrees. Ray of light strikes a thick sheet of glass. And now I want to find what is the refracted ray. So what happens here is part of it is reflected, and then part of it is refracted. And now I want to know what is this angle, theta 2. So that's just going to be 1 sine of 25 equals 1.5 sine of theta. And so theta is the inverse sine of 25. It's 16 degrees. That's A. Light is incident on an air to glass boundary at an angle of 30 degrees. Refracted at an angle of 21 degrees. Want to know what is the index of refraction. So it's 1 sine of 30 equals n sine of 21. And solving for n, which is just sine of 30 over sine of 21. 1.39 or 1.395 or 1.4. That's B. If the speed of light through an unknown liquid is measured, this is V. What is the index of refraction? Okay, well, I know that V is C over N. So N is C over V. Uh, 1.67. Fiber optic cable is submerged in water. What is the critical angle for light to stay inside the cable? So this is my cable. This is n equal 1.5. This is n equal 1.33. So my light ray comes up here. I want to know what is this angle to cause the light ray to go at 90 degrees. So that's 1.5 sine of theta equals 1.33 sine of 90. So theta is the inverse sine. This is for the critical angle of 1.3 over 1.5. It's 62.5 degrees. That is D for number 5. Dispersion of light by a prism is made possible by which of these phenomena? Remember, this is when I have light that comes in, it's dispersed into its different colors of light. And that's because of the wavelength dependence on the index of refraction. So if I look at n versus lambda, it looks something like that. So that's D for number 6. Following shows a fiber optic cable. In order for total internal reflection to occur, which of these statements by the indices of refraction must be true? Remember, for total internal reflection to occur, the ray of light has to bend away from the normal. So if I think about my wave front coming over here, that means that it's going to be traveling faster in N2 than it is in N1. That means that the index of refraction in N2 is less than N1. Now let's see, that's A for number 7. Consider this arrangement of mirrors. What is theta R? So if this is 50 degrees, this is also 50. That means that this is 40. 120 plus 40 equals 160. So that means that this angle is 180 minus 160, is 20, which means that this angle is 70, 90 minus 20, and so this angle is also 70 degrees. So number 8 is A. Organize the types of radiation from lowest to highest energy. Let's see, the lowest of these is the microwaves, followed by infrared, visible, and then gamma rays are the highest. So let's see, looks like microwave is microwave, infrared, visible, gamma. That's right, so it's B for number 9. Microwave is really just a type of radio wave, a little bit shorter wavelength. Which of the statements best characterize the indices of refraction? I like to draw my wave fronts. It's going to slow down when it enters there, and this wave will swing around at a higher velocity. So if N2 is a lower velocity, that means it has a higher index of refraction. So that is A for number 10. Image is found to have a negative image distance. What best describes it? Okay, negative image distance means that it's virtual. If it's negative image distance, that means that it's upright. If it's a single element, like single lens or mirror, could mean that it's smaller, but not necessarily. And imaginary, that's not really anything to do with images. Mirages are caused by which of these phenomena? Remember, it looks like reflection, but it's actually caused by refraction. The following figure shows the configuration of object, lens, and mirror. Or excuse me, object, lens, and image. What kind of lenses produce this image? This is an upside down image. Oh, sorry, yeah, so this is a lens that is a convex lens. If I imagine my rays coming through here, parallel to the axis, through the focal point, parallel to the axis. Right, that is a convex lens. Concave lens cannot form an image like that. So that is C. For number 13, consider the system of lenses. Where is the final image located? Oh, so this is P1, so I can find Q1, which is 1 over P1, 1 over F1 minus 1 over P1, so the negative 1, that's 1 over 15 minus 1 over 30, so the negative 1 is 2 over 30 minus 1 over 30, which is 1 over 30. So it's 30 centimeters. That means that my image is right here. My magnification is, let's see, you don't have to find the magnification. I'm going to go and do it here. It's negative 30 over 30, so it's negative 1. So that means that my image, same side as the object, but inverted. So my distance for P2 is 60 minus 30. That's equal to 30 centimeters. And so it's the exact same problem as it was before. So Q2 is also equal to 30 centimeters. M2 is also going to be negative 1. And so my image is going to be over here. That's not really to scale. It's the same size as the original object. So my Q2 equals 30 centimeters. And that's to the right of lens 2. So the answer is D. For number 14, you stand 2 feet away from a plane mirror. How far is it to your image? All right, Q is equal to P, so it's 2 meters. That's D for number 15. Virtual image is formed along the principal axis 10 centimeters from a concave mirror. Focal length 15 centimeters. What is the object distance? So this is a virtual image, so Q is negative 10 centimeters. The focal length equals 10. What is the object distance? What is P? One over 10 minus 1 over negative 10. The negative 1, that's 2 over 10 inverted. It's 5 centimeters. Did I do that incorrectly? Oh yes, I did. I'm sorry. The focal length is 15. So my focal length here should be 15. What is this? 2 over 30 plus 3 over 30 to the negative 1, that's 5 over 30, or 30 over 5, which is 6 centimeters. So the answer for 16 is B. The following best describes the image of a concave mirror when the object's distance from the mirror is less than the focal point distance. So remember, this is concave mirror. This is your object right here. It's a virtual, if you recall from in class, this is like a makeup mirror held up very close. It's virtual, upright, and bigger. Virtual, upright, and magnification greater than 1. That's B for 17. When the reflection of the object seen in a convex mirror, the image will always be virtual. This isn't a mirror like this. The image is always virtual, upright, and smaller. I was just asking about virtual or real. If atmospheric refraction did not occur, how would the apparent time of sunset be changed? This is the Earth. This is the sun. Rays come here, but because of the atmosphere, rays are actually bent around so the observer can see them. But if that didn't occur, then sunset would occur earlier. For 19, should be B. Like if you didn't have the atmosphere, then it would occur at this time instead of at this time. So it would actually occur earlier. Sally places an object 6 centimeters from a thin convex lens along its axis. Focal length has a lens 9 centimeters. What are the respective values of the image distance and magnification? So the focal length is 9 centimeters, but it's positive 9 centimeters because it's convex. The image distance, I want to know, P is 6 centimeters. So that's 1 over F minus 1 over P to the negative 1. So 1 over 9 minus 1 over 6. Get negative 18. And then my magnification is negative Q over P. So Q is negative 18 and magnification is positive 3. That's B. Which of the following effects is the result of the index of refraction will vary with wavelength? That is chromatic aberration out of these. Remember, I have light rays that come in. And because the index of refraction varies with wavelength, these different light rays focus at different points. Reducing the lens aperture size as a scheme, one can reduce the occurrence of spherical aberration. Light rays coming in the outside, focus at a particular point. Coming on the inside, focus at a different point. So if you mask out this region of the lens, it gets rid of this part of the image. There's all the answers.